I like salt.
Do you?
It's good.
Yeah.
Yep.
Not necessarily always good for you.
And small quantities.
Yeah, well,
yummy.
depends on your amount and what you're doing,
Yeah.
like in my story with the Gatorade from the previous podcast. Hey, Mr. Sams, you kind of lied to us a little while ago.
I'm sorry.
Yeah, I know. You were telling us that when you put an acid and a base together, that it's completely neutral.
Well.
Yeah, so that wasn't exactly true.
No.
So what we want to get at today is we want to explain that.
Yeah.
For lack of a better term. It's
Right.
kind of a little more complex than we've alluded to, so this is kind of an advanced topic. But
Right.
salts can have a pH.
Mm-hmm.
Huh? Salts?
Some salts.
Now, what's a salt mean?
Not all. A
Let's
salt
review
is
that.
an ionic compound.
Remember, salt equals ionic
Right.
compound.
Now, some do and some don't.
Yes.
So, like your typical table salt, NaCl, sodium chloride,
pH 7.
pH 7 does not have a pH.
But some salts can.
Mm-hmm.
All right. Now, how do we know that? Salts that contain the components of a weak acid or a weak base have a pH.
Yes, they do.
Other than 7.
Yep.
All right. It's important to understand. And we're going to do a bunch of examples, or a few examples, to help you
Yeah.
understand it. This is it's a good topic. You take AP, you're going to get very used to this.
Oh, yes.
So,
acetic acid, that's our nice common weak acid.
well, not acetic acid, we're going to do sodium acetate.
Right. Well,
So let's say I have sodium acetate, NaC2H3O2. That is a salt that we have in the back of our
Yes.
room, common chemistry supply thing. So if I have sodium acetate, sodium actually comes from a strong acid. So
Nope.
a strong base, thank you. Strong base. And acetate...
which strong base would that be?
A sodium hydroxide.
All right.
And acetate's kind of his buddy, if you will, is...
Acetic acid.
acetic acid. And so and acetic acid is a weak acid.
Right.
And so when we look at these reactions, what really matters is the acetate.
Right, because it is a cousin of a weak thing.
Yes.
Whereas the sodium is a cousin of a strong
And
thing.
remember, there's something we said earlier, that strong bases and strong acids have weak bonds. And weak acids and weak bases have strong bonds. And so this is kind of this is because of that. So what's going to happen is, so let's react this. And typically we need to react it with water. So I'm going to write sodium acetate, NaC2H3O2. I'm going to react that with water. Now for water, it's probably best to write it as HOH, remember? All right, and what's that going to make? Now, acetate likes to get together with the hydrogen ion to make the weak acid HC2H3O2 negative.
Right, because remember, weak things like to stick together. They don't like to dissociate.
So this has a strong bond in it, right? And then the OH is going to get together with with the sodium. That's going to make NaOH. Now, however, this is a strong base. And what that's going to do, because strong bases we learned in earlier podcasts,
split apart.
They split apart. So it's actually incorrect to write this like this. You would write this as Na positive plus OH negative, because he completely dissociates.
Yep.
And so as it turns out, when you do this, when you have this particular salt, since it produces free hydroxide ions, it's a base. So this is a basic solution. So if you take sodium acetate, you stick it in water, and stick a pH meter, it's going to read 8 or 10 or some high number higher than 7. Okay. Let's do another example.
Okay.
Let's do another example, Mr. Sams.
Let's do ammonium chloride.
Ammonium chloride. So if I take NH4Cl, that's ammonium chloride. I'm going to react that with water. HOH. What's that going to do? Now, ammonium, his partner, if you will, is ammonia, and that's a weak base. So he came from a weak base, and chloride came from a strong acid, hydrochloric acid.
Right.
So the H is going to get together with hydrochloric acid and make
HCl. But that's strong, so it's incorrect to write it together.
And so then that's going to make in the other thing. Well, yeah, okay, we dissociate it now. So that's a strong acid. We write it as H positive plus Cl negative, because he's like a high school romance and they all break apart.
Yep.
And then the NH4Cl, no, what am I doing wrong here?
NH4
OH.
OH.
NH4OH will be formed.
Right.
And then that leaves free hydrogen. That makes this an acid.
Yep.
And so this substance, if you take ammonium chloride, you drop that in a water. It's a solid, by the way, so you have to put it in water. But when you put it in water, it reacts and it makes free hydrogen, so it would be an acidic, pH 5 or something like that. It's not super strong, by the way. They typically, these types of salts, it's not like you're going to get a pH of 1 or 14.
Right.
You're going to get a pH, 5 or 8 or something like that. So that's how salt hydrolysis works. Why is this important? Well, this is why the pH at the end point is not equal to 7. So remember when we did this graph a little bit ago?
Yeah.
You saw this graph. This is a little different, but a same graph.
Right. Now, in this particular one, the end point is at pH 7, I think.
No, it's not. No, I'm calling it.
Okay, a little bit higher. Okay. Now, let's qualify this real quick, though. If you titrate a strong base with a strong acid,
pH 7,
then you're going to end at pH 7 because you're going to have water and you're going to have something like sodium chloride that does not have any acidic or basic properties.
If you had a strong acid and a strong base, the graph looks like this, and this number is 7. But this one here, we have a weak acid with a strong base is what I'm guessing. We don't have the exact numbers on this. But and this pH is greater than 7.
Yeah.
Because of the presence of, let's say this was the acetic acid we did. We had HC2H3O2 acetic acid, and it's that presence of that extra hydroxide after the reaction takes place. Okay.
Would it be helpful to write the equation, the titration equation, to show them what's left?
Yeah. So
let's do that.
So what Mr. Sandwich is saying, HC2H3O2, if that was a reaction, it reacted with sodium hydroxide. We said that the sodium is going to get together with the
acetate.
Yeah. So it makes sodium acetate.
And HOH.
And HOH.
And as we just saw in a previous slide, we had sodium acetate. When we had that in water, it was basic.
Yes, because it's this substance that then produces the hydroxide.
Right.
That, it's the presence of this. And technically, actually, Mr. Sams, it's actually the C2, let me show you this, C2H3O2, that's the part that actually reacts.
Because the sodium we saw didn't end up reacting with anything.
Because all of these acetic acid and sodium hydroxide at the equivalence point, the moles were equal. They're gone. And the only thing left, and this produces the HC2H3O2 plus the hydroxide
hydroxides.
And it's this bugger that makes this pH 8 or 9 or whatever it is. Yeah. Okay. Conversely, you can also add a base to an acid. So if I were to have, this is the example here, if I take ammonium, ammonia.
Ammonia, yeah.
If I take ammonia, this with this reaction. You should sketch this, by the way, and then write down the reactions. Ammonia, and I react it with HCl. That's going to make ammonium
chloride
plus chloride. It'll dissociate.
Yeah.
Now, the key chemical here is the ammonium. And if I take the ammonium and react that with water, it's going to make ammonia plus, there's something kind of new we need to talk about, H3O positive. This is actually the same thing as H positive. They're the same thing, the hydrogen ion, except it's got the water attached to it. It's actually more accurate to say hydronium, but chemists get lazy and they write H positive. And that's why the pH here is like 5.
Which is acidic pH.
It's an acidic pH because this substance, at the equivalence point, the only thing you have left that's of any consequence is ammonium, but the ammonium reacts with the water to make some hydrogen or hydrogens or hydronium ions, and that's why you get a pH less than 7.
Yep.
Okay. That, my friends, may be your last podcast of the year.
I think it may be.
Depends on the year, but
and it depends on
our decisions and a lot of things. But it is possibly your last podcast of the year. So now you get to finish and start or whatever
project
the final
time.
Project. So you have lots of things to do. The project is the greatest thing we do.
Yes, those of you who are not in our classrooms, who are watching this out in internet land, we hope you enjoyed them.
Yes, and we still may do more.
We may.
Yeah, but we'll see you later. Goodbye.
Bye.